These are test chambers at the U.S. Department of Energy Lawrence Berkley National Laboratory, a place where researchers like intern and high school chemistry teacher Alan Boltz are heating things up. Cook stoves like these are used by people across the globe.
Between 2.5 and 3 billion people, so about half the world's population, cook on open flame every day for their food.
The problem is that a lot of these use charcoal for fuel, and not very efficiently. And since charcoal is a fossil fuel, that means it's giving off CO2.
The amount of, particulates, like if you've ever been around a campfire and you get that soot on you, it's like all that soot goes up into the atmosphere. Now multiply what you just did once by 3 billion 3 times a day. So the numbers, when we look at it that way in terms of that exponential impact, then it really began to make sense in my mind, the need for more fuel-efficient stoves.
There's another big problem too. Charcoal takes a lot of wood to make, and in countries that rely on it, like Haiti, forests are almost gone. This NASA image tells the story. The green on the right is the Dominican Republic. The brown, that's Haiti.
In Haiti, about 98% of the country has lost its forest due to the production of charcoal. So they're kind of working at an environmental deficit right now.
That's where this lab comes in.
And the Berkley Lab was basically asked to test all the stoves to look at efficiency. That way, as the NGOs or non-governmental organizations in Haiti are distributing the stoves, they'll have an idea of what's the most efficient versus the cost and ease of use and all those other variables. It's definitely climbing.
Here they're using a 3-phase international standard water boiling test to see which ones do the job.
At this elevation, the boiling point here is actually 99.9. We just had to transition, take all of our measurements, how much charcoal was still in there burning, how much water we had lost due to evaporation and boiling. And now we want to get it at a simmer point and keep it there for 45 minutes. And that simulates basically cooking rice or beans.
They already know traditional stoves aren't good options, though they're popular because they're easy to make.
One of the downsides of it is they're pretty inefficient. Because of the large fuel size, you could really stuff them full of charcoal, which a lot of that is then going to go to waste as heat that's escaping out the sides.
This one's not much of an improvement. To get that, you need 2 things. A smaller area to put fuel.
You see efficiency go up just because people can't overfeed it.
And insulation.
Based off of the physics and the mechanics behind heating, we are going to see an increase in efficiency with insulated stoves, just like you would at your house.
This one's a modified version made in Haiti.
The clay itself will hold a lot of heat and be able to give that heat back during longer cook cycles.
As for the one over the coals right now, it uses fiberglass instead of clay, which works too. At the end of the day, Boltz says it's about finding a solution now.
With this information, as soon as we get the analysis and the efficiency, it'll be used immediately in Haiti to help the people there now.
It's helped not only in terms of energy efficiency and cleaner air, but also for saving what's left of Haiti's forests too.